All right, this is 3.3C, and the first thing we'll be talking about is adrenal gland and the how adrenaline works. So how adrenaline works is you start with the stimulus. So this is a flow chart again. You start with the stimulus, and this is detected by the amygdala in your brain. Amygdala. The amygdala signals the hypothalamus via nervous message, the nervous system. So through neuron, hypothalamus. And this goes down to the adrenal gland. I don't have much space here. Zoom out a bit. Adrenal gland. Adrenal. All right. And the adrenal gland will then release the adrenaline into the blood. And of course, its functions include dilating your pupils so you can see better, increase heart rate so you can the blood is pumping around the body faster, dilate blood vessels in the skeletal system, increase blood pressure as a result of increasing heart rate. It will also reduce the blood flow to non-essential organs. That's why you get the sick feeling after getting a shock, right? After um, like you feel sick, you want to vomit after like a close call, or increase blood sugar levels, and also increasing breathing rate so you can get more oxygen in, so your body can perform aerobic respiration more efficiently, as well as dilating air passages to get more air into your lungs. So that's the main roles, the main functions that adrenaline has on your body. A second diagram we need to know is CO2 level regulation. So CO2 is acidic, and as we know, something that's acidic has a pH of lower than 7 pH. To the left we have, let's say 0, and to the let's say 1, because I don't know if they have 0 pH. 1, and on the right we have say 14. And in the middle, we have 7. 7 will be neutral. So lemon juice will probably be around 2, 3. And baking soda will be on the right because it's basic. And CO2 makes your body go acidic. More CO2 in your blood just means your body will have decreased pH, while having less CO2 in your blood will just means your body has an increased pH. So let's get rid of this and draw two scenarios. Okay. Let's say your body has low CO2, and on the other side, you have too much CO2. Now, this could be due to breathing too much. If you actively breathe, like using some sort of breathing method, and you do that for 10, 20 minutes, you could actually get rid of a lot of CO2 in your blood. You start to feel dizzy, and some people actually black out from this. This is the technique that some people use to hold their breath longer, like for 7 minutes, crazy amount of time. And when you have too much CO2, that could be, when you're running a marathon and you're not breathing enough, or your body is just doing too much at once, so you can't keep up with the breathing. That's when you have too much CO2. So let's talk about what happens when you have not so much CO2. As a result, your pH becomes more alkaline. And what your body wants is to regulate the pH back to the normal level. So as a result, you have four responses: two from the nerve signal, and two involving hormones in this response. So you have the first one, rib muscles to relax and slow breathing. All right, you're breathing too much. So chill out, dude. Stop breathing that fast. The second one is the diaphragm muscles, slow breathing. Again, stop breathing so much. And the two hormone ones are thyroxine and adrenaline. And we know what these hormones both do. They increase the cell activity. They increase your metabolism, and the result, and as a result of metabolism, CO2 is being made. Vice versa, we can guess what is going to happen on the other side. When you have too much 2H, you gotta breathe more. So your rib muscles are actually going to tense to increase breathing rate, and your diaphragm muscles are also going to increase the breathing rate. As a result, you don't want too much metabolism in your body right now because you already have enough of that. So your body is going to crank down the adrenaline and the thyroxine to reduce the rate of cell respiration. And that's topic 3.3D. Thank you.